Now here's the infamous graph. We want to take limits. So this says the limit as x goes to positive infinity, x going to positive infinity. This says y is going to 0. Negative 4 from the right. We can see y is going to positive infinity. 1 from the right. 1 from the right, I end up at y equal 1. Now if I look at 1, I'm going to use both fingers. I end up in two different places. And so that means that the limit doesn't exist. Negative 2, I end up right here, which is y equal 1. And 3, I end up at that open hole, or 5. And what are the values where x is not continuous? The problem is I don't know what's on the other side of this. This could go up forever and ever, and there was no notation to say that this was a vertical asymptote. It would be discontinuous at negative 4 if it were a vertical asymptote. I think that was my original intention. However, if you said negative 4, I gave you credit. But as this stands, I know for sure that it's negative 2, positive 1, and 3. And if you put negative 4 in, I gave you credit for that. This is where I screwed up. It says for what value of x at x equal 1 for x to be continuous. Well, at x equal 1, it's a jump discontinuity. There is no way on God's green earth that this thing will ever be continuous. I actually meant for x equal 3, and that would have been 5, but I screwed up. So I gave you credit for this, and so we just say these are extra points. Because there is no solution, really. That's for this guy. No solution, because you have a jump discontinuity. So I just basically, we're still a 100-point test. I just don't count this at all. For x not equal to 4, because I'd have a division by 0, what value should be assigned to h of 4 to make h of x continuous at 4? Well, the first thing I have to do is I have to reduce h of x. And this is x plus 5, x minus 4 over x minus 4. X minus 4 reduces out. So h of x is x plus 5. X can't be 4. Now remember what this yields. This is a hole. So it's a hole at x equal 4. So what is the value at that hole? Well, that's h of 4, which is 4 plus 5, or 9. So essentially h of 4 would have to be 9 in order to have it be continuous. That's the same question that I screwed up on part H above. That's essentially what would happen. There's a hole in the graph. What's the value at the hole? Value at the hole is 5, which would be f of 3. If that were actually filled in, it would be f of 3.